Okay, you guys ready to do it?
Is that 3 feet going to?
Oh, no.
It's to the top of the
Yeah,
circle?
to the top of the
Okay.
circle. My drawing is not very good. Yeah, 3 feet going to the top of the circle. All right, so we're gonna set this up, right? We're looking for the force on a slice, the force as a sum, and the force as an integral, right? Okay, so what do we need first? A
Formula.
Axis.
Oh, no, coordinate system, yes.
well, yeah, we need. Okay, so where do you guys want to put the axis?
Let's put it right at the water level.
Water level. Okay, so let's say we put it here. Ooh, I can't draw straight lines. Okay, so and we'll point it down, right? So y is facing down, and then we'll draw a slice. So let's say, since the I don't know, something like that. And the slice has thickness delta y, right? Okay, so we're trying to figure out the force on this slice right here, right? So to be able to do that, we need to find the area of that slice, right? Okay, so the area of the slice. So the area of the slice is going to just equal to the length times delta y, right? Length times width, so the length is whatever that is, right? And the width is delta y. So my big question is, well, how do I find that length, right? How do I find the length of that whole thing?
The arc's going to give you the section of the circumference. It's not going to give you the whole area between them.
Oh, sorry. So any ideas?
You can find the length of the side that is parallel to the center line of the circle. By subtract. Basically, 3 plus the radius minus y.
So, well, the thing is that it's changing as you go down, right?
Yeah.
So it's dependent on y. We know that the radius is 2, right? So like this line right here is going to be equal to 2. Yeah, so there's 2 ways to do it. You can either do it using the equation of the circle based on the position where it is, or you can just do it using the Pythagorean theorem, right? Because you know that right here, so the length of the hypotenuse is 2. What's the length of that side right there?
That's going to be 2 minus y value.
Well, no, be careful,
Yeah.
because so the axis is right here, right?
Crap.
Y sub minus 3.
Yeah, so it's 2 minus 5 or whatever.
Yeah. So it's going to be, so the distance from, so see how the distance from here to the center of the circle, that's equal to 5, right? And the distance from here, well, from, let's see, okay, the distance from the water to the point where the slice is,
Thank you.
what is that?
5 minus.
No, the purple.
What do you want?
The purple is just y, right? That's the y value where the slice is located at. So then that little piece right there is 5 minus y, right? So that means that the little chunk that we're looking for, this blue part,
I think I might just looked it around.
is then the square root of 4, right? Hypotenuse, 2 squared minus
Square, yeah,
5 minus y sub I
squared.
squared. Okay? So, and then the length is, that's one piece, right? So the length is twice that, right? Because that's this little chunk, and so the length is twice that. So the area of the slice is equal to 2 square root 4 minus 5 minus y sub I squared. And then delta y, right? Does that make sense? No, it doesn't. So all right, so then the force is equal to the density, right, times the depth times
Area.
the area. Okay, so this is, so we'll just leave it as omega, right, the density. The depth is, the depth is what? Well, make it pounds per cubic feet, right? Might as well. Okay, times the depth, which is, what's the depth of the slice? Y, right? Because that's where, because we set our axis at the water level, so then that means that the depth of the slice is y sub I feet, right? Times the area, which is what we just wrote down, right? 2 square root 4 minus 5 minus y sub I squared delta y square feet. And when we multiply all that together, the feet go away, right? And we're just left with pounds. What all that stuff is. So then the force, let me go down a little bit. So the force written as a sum is, so the force is approximately equal to the sum from 1 to n of each one of those slices, right? So omega, well, let's put 2 omega y sub I square root of 4 minus 5 minus y sub I squared delta y pounds, right? And then as an integral, so we write it down as an integral as the force is equal to the integral of 2 omega y square root 4 minus 5 minus y squared dy, and then this is where we have to bring out our brain again, right? And put in the limits of integration. So we're from where to where do my y values go?
3 to 7.
They go from 3, y equals to 3, right, which is right here, all the way to the bottom of the circle, which is 4 feet down, right? So from 3 to 7. And then whatever that is equal to, which you can use your numerical integration program, to find